Hello everyone. In this video, I am going to explain one more problem based on graphical convolution method. Now, let us begin the class. The question, find the convolution of following signals given x of t signal as u of t minus u of t minus 2 and h of t signal as e power minus t into u of t. Now here, these are the two continuous time domain signals. By using these signals x of t and h of t, we are going to find the output signal y of t by using graphical convolution method. Now here, firstly we need to represent the signals u of t. Here is the u of t signal and this is the u of t minus 2 signal. That is nothing but it is the delayed step signal by the time instant 2. Now, by subtracting this u of t and u of t minus 2 signals, we are going to obtain x of t signal like this. And this is the h of t signal given in the problem. That is the exponential decaying signal multiplied by step signal means we are going to obtain the h of t signal will be like this. Now, by moving graphical convolution steps, in step 1, we need to represent the given x of t and h of t signals on independent variable tau axis. Now, this is the x of tau signal with independent variable tau and this is the h of tau signal with independent variable tau. Next, we need to represent the reversal of h of tau signal. So by that one, we are going to obtain h of minus tau signal in this manner. Now we will move to the step 2. So in step 2, we are going to represent both the signals x of tau and h of t minus tau signals on same tau axis. So this is the signals we are obtaining x of tau and h of t minus tau, nothing but we are going to consider a time shift t going to be the most negative number so that we can draw the h of t minus tau signal on second quadrant. So the signal will be like this. Now by observing these two signals, we say that there is no overlapping area in between two signals. So the output signal y of t is equal to 0 when t is less than 0. So when this t is less than 0, there is no overlapping area between two signals. Next, if we move h of t minus tau signal towards right side, we may see that there is some overlapping area. See here, this is the overlapping area we are observing. And here, in between two signals, the overlapping area integral limits are going to be 0 to t here. So, by considering these integral limits, if we consider this principle, y of t equal to integration minus infinity to plus infinity, x of tau h of t minus tau d tau. Now, x of tau signal will be equal to 1 and h of t minus tau signal is equal to e power minus of t minus tau d tau. Now, by considering common integral limits 0 to t, if we do integration, the output signal y of t, we can obtain here y of t equal to 1 minus e power minus t in the interval 0 less than or equal to t less than 2. So in this interval, the output signal y of t will be like this. Now we will see the graph when t is greater than or equal to 2. Now, by considering t is greater than or equal to 2, this is the overlapping area we may observe between x of tau and h of t minus tau signal, so that the output signal integral limits are going to be from 0 to 2 from this graph and x of tau equal to 1 and h of t minus tau equation is going to be e power minus of t minus tau d tau. So, by integrating this expression, we may obtain output signal as y of t equal to 1 minus e square of e power minus t in the interval when t is greater than or equal to 2. Now, in this given given question, the evaluated output waveform is going to be like this, and the mathematical expressions for the output signal y of t is equal to 0 when t less than 0, and y of t is equal to 1 minus e power minus t in the interval 0 less than or equal to t less than 2, and y of t is equal to 1 minus e square of e power minus t in the interval t greater than or equal to 2. Now, by following this procedure for given two continuous time domain signals, we may obtain the output signal y of t by using the graphical convolution method.